This week we're going to start doing polynomials, part 1 of 2. So next week we'll do more advanced polynomials with more like competition polynomials. So this week is more of like what you would normally learn in Algebra 2, maybe. Yeah, so this is normally what you would learn in Algebra 2. So today's like a foundation for next week. Next week we're doing more competition polynomials. Today is like more of like the basis, the background, all that kind of stuff. Okay. So we're gonna first define a polynomial. What is that? We're gonna do the binomial theorem, polynomial division and factoring, and then we're gonna do the remainder theorem. Those are the topics for today. So those are all things you would learn in Algebra 2. So if you're in Algebra 2 already, these should be more like but next week we will be doing competition math with polynomials, more advanced stuff. So how do we define a polynomial? There are 3 words we can use to, the 3 like special types of polynomials. These are a monomial, a binomial, and a trinomial. If you think about bikes, well, mono basically means 1, bi means 2, and tri means 3. Tricycle, bicycle. For like a one-wheeled bicycle thing, it's actually called a unicycle. That also means 1. But mono means 1, which basically means that a monomial has only 1 term, like 3y. That's it. Or like 1, just a number. That could be a monomial. We could have a 9y squared. Okay, so it can only have 1 term. 9y squared plus y squared, that's still a monomial because we can combine like terms, right? This is 10y squared, so this is still a monomial. Although it has 2 terms here, we can combine them. So we only categorize them once we combine them, okay? A binomial has 2 terms, okay? Any binomial has 2 terms, so it's going to be like something plus or minus something else. We would have like 3x squared, 5y cubed, and that could be a binomial, okay? Then we've got a trinomial. A trinomial has 3. So these, I think you should be able to guess what a trinomial is. We got 3 things that are different, like different kinds of terms. So we can't combine them together. So we have 3 separate. Like that's a trinomial, okay? So all of these are actually called polynomials, all of them. Okay, all of these are called polynomials. And if we have 4 terms, there's no special word for that, but that's also a polynomial, okay? Let me accept someone into the room. If we had 4 terms, that would still be a polynomial. 5 terms, polynomial. 6 terms, polynomial. There's just no special words for those, but they're all polynomials. Now we're going to go on to the binomial theorem. So this only works for binomials. And you can see that we've got a binomial here, x plus y. If we take that to the n power, okay, so let's say we have x plus 1, n power. Let's say n is 5. Okay, we just have that. Y in this case, y and x are just variables. They can be replaced with anything you want, okay? We can replace the y. In this case, I replaced the y with a 1. You could replace the x with like x squared. These are just variable placeholders, but they could really be anything. X just corresponds to the first term in the binomial. Y just corresponds to the other term in the binomial. Okay, I'll just make this back into an x. Simplicity sake. So what the binomial theorem tells us is that if we have a binomial raised to some kind of integer power, it has to be an integer, a positive integer. This is actually going to, this tells us how we can expand this. How do we expand this out? Of course, we can always multiply it, right? We can do x plus 1. Oh, we can multiply it out. That would take a little bit of time, though, right? Do you like to multiply all these with like the FOIL method? No, that would take forever. So we don't really want to do that. So the binomial theorem is actually a trick. So if you look at all this junk here, this is the actual formula for it. But this is a little complicated, right? I'm not going to expect you to understand what this means. But this basically means that this is called a summation notation. It basically means we're going to take a sum. So first, what it does is we're going to take k equals 0. We're going to set some kind of value k and set it equal to 0. The first term of this sum would be this. If k equals 0, then we've got n, choose k. Remember, I have k equals 0, and we have x to the k, x to the 0, times y to the n minus k, 5 minus 0. Y is 1, right? Remember, y, I set that as 1. Okay, so that's basically what this means. I'm taking k equals 0, and I'm evaluating this number here. Then I move k up 1. So now k is 1. I add a new term. The new term is still this, but k is equal to 1 now. So n is still 5, choose 1, because k is 1, times x to the 1, y to the 4. N minus k is 4 now. That's the next term. Now I add the next term if k equals 2. Okay, so now I'm going to do the same thing. 5, choose 2, x squared, y cubed. Okay, remember y is still 1. Y is just a placeholder here. Y just corresponds to the second term in your binomial. Okay. Now, I'll do it again. K is 3. I'll move it up again. K is now 3. I will do 5, choose 3, x to the third, 1 squared. Okay. So again, plus 5, choose 4, x to the fourth, 1 to the 1. Add one more, 5, choose 5, x to the fifth, times 1 to the 0. So now, if you see this number here, n, this means this is the limit. Once we hit n, we stop adding. So it looks like we've hit k equals n here, right? When we have k equals n, we will stop adding, right? So it makes sense, right? If we were to keep going further, we'd have 5, choose 6, and you can't choose 6 out of 5. That would be impossible. So this is basically how that formula works, all right? So if you see now, I can evaluate all this stuff. 5, choose 0, what is that? 1. This goes away. I can evaluate all these chooses. 5, choose 1 is 5. 5, choose 2 is 10. 5, choose 3 is also 10. 5, choose 4 is 5. 5, choose 5 is 1. You see here, I'm multiplying a bunch of 1s, so these basically don't contribute anything to my actual product, right? If we multiply something by 1, it's still the same thing. I can take all those 1s out. They don't matter. So now you can see that we've got x to the 0, which is 1. Anything to the 0 power is 1, plus 5x plus 10x squared plus 10x cubed plus 5x4 plus x to the fifth. And that is the expansion of x plus 1 to the fifth power. Okay? If you were to manually multiply that out, you get the same thing, but this is actually a lot faster than that. Okay? So let me do another example for you guys. With this polynomial, let's expand that. So it has to be a binomial inside. So here, 2x squared is corresponding to x. -1 is corresponding to y. Okay? Because here it says x plus y. X is actually adding to a -1. So y is -1. X is 2x squared. These are just placeholders that tell us this is the first term, the second term. All right? The first term is here, the second term is here. Okay? Let's evaluate this. So first, we're going to start with k equals 0. So if k equals 0, what is the value of this? Well, it's going to be, we're going to first figure out n. N is 4, right? So if k is 0, the first term is 4, choose 0, times x. X, remember, that's 2x squared, to the k value, k power, which is 0, times y, remember y is negative y actually, to the n minus k. 4 minus 0, 4. Okay, now the next term, we'll move k up to 1. K is 1 now. What do we got? Oh, 4 choose 1. 2x squared to the 1, negative 1 to the 3. Right? So n minus k is 3 now. Now let's move k up again. K is 2 now. What do we have? 4 choose 2. Oh, that's a fraction now. 4 choose 2 times 2x squared to the second power times y to the second power. Well, remember y is negative 1. Okay, now we add the next term. Let's move k up to 3. If k is 3, then we got 4 choose 3 times 2x squared to the third times negative 1 to the first. Let me go again. K is 4 now. 4 choose 4. 2x squared to the fourth, negative 1 to the 0. Now we stop. K is equal to n. So this part basically tells us we stop at n. So k is equal to n now, we stop. So if we go any further, we'd have 4 choose 5, which wouldn't make any sense. This is it. This is the actual expansion of this. So if I were to evaluate this, and let me replace all the chooses with their actual values. 4 choose 0 is 1. 4 choose 1 is 4. 4 choose 2 is 6. 4 choose 3 is 4. And 4 choose 4 is 1. Let's evaluate all the negative 1 powers. Negative 1 to the fourth is just normal 1. Negative 1 to the third, oh, that's negative 1. Negative 1 squared, that's just regular 1. So we can basically take it away then, right? So, because if we multiply something by 1, it remains the same. So negative 1 to the first power is actually just, it actually has to be negative 1. Make sure we know these are multiplying. Negative 1 to the 0, anything to the 0 is 1, right? So this can go away. Let's take all the 1s away because they don't do anything. So you can see now, let's actually evaluate the 2x squareds now. 2x squared to the 0 power, that's 1, because anything to the 0 power is 1. 2x squared to the 1 power, well, the 1 power doesn't do anything. Okay, so now we just got 2x squared. 2x squared squared, remember the exponent has to distribute in there. So we got 2 squared times x squared squared. So it's 4x to the fourth. Same thing here. This has to turn into, the 3 has to distribute. So we got 2 to the third times x squared to the third. 8x to the sixth. Finally, 2x squared to the fourth power is 16x to the eighth. Now it looks like we can just add these together. Let me actually just write it here. I have to write the biggest exponent first. That's just how I like to do it. 16x to the eighth. We got 4 times 8 times negative 1 as our coefficient, which is negative 32. X to the sixth. 24x to the fourth. Negative 8x to the second. Plus 1. And this is what happens if you expand this out. Okay. It may look like pretty complicated. It is pretty complicated, but it is a lot faster than just manually multiplying it out. Okay. So yeah, that is the binomial theorem. Any questions? Nope. Okay. So if you need to review this anytime later, I would not recommend actually memorizing this formula. Just memorize the first term you have to multiply by 4 choose 0. And you take the 0 power and then 4. 4 choose 1, 1 power, and then 3. Okay, so stuff like that. So the 6 times a set in, but this is what's basically taught at Algebra 2. At least for when I went to Algebra 2, this is what they taught. So if you've learned this already, this should be more or less like review. So I guess that's why a lot of you don't have any questions. So hopefully we're clear on that. Let's expand these two binomials. Okay, x plus 1 to the fourth and x minus 2 to the fourth. Don't bother chatting me the answer because it's going to take a while to type it in. So I'll give you, let's say, 5 minutes to evaluate these, and then you have your answer. You can just check it with what's on the screen. Okay. Okay, so let me go over these. The first one. So basically what I like to do is I don't remember the formula. I know the first term is 4 choose 0. Second term must have a 4 choose 1, 4 choose 2. Right, so the terms have like these 4 chooses in them. Right, so now the next part is figure out the x. Well, the first term is going to have x to the 0. Next term is going to have x to the 1, x squared, x cubed, and x to the 4. I got to figure out the y. The first one has y to the 4th. The second one has y to the 3rd. The third one has y to the 2nd. The fourth one has y to the 1st. The last one has y to 0. And that's basically it. You don't have to memorize the formula. You just figure out, oh, what's the pattern? And this is basically what it does. Okay? Remember that y is 1 here. Y just means the second term of the binomial. So 1, 1, 1, 1. Well, 1 to anything is 1. So sorry about that. So x, y, 1 to the anything is just 1. So just take all those out. X to the 0 here, that's 1. So basically, got 4 to the 0 power. That's 1. 4 to the first power, 4. 4 to the second, 6. For the third, 4 choose third, 4 choose 3, 4. 4 choose 4, 1. Voila, now I got x to the 4th plus 4x cubed plus 6x squared plus 4x1. That's it. All right. And now to the second one. Second one is basically the same exact thing. So we got a 4 choose 0 term, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Now let's figure out the x term. Well, the first term in the binomial here is just x. So the first term has x to the 0, x1, x squared, x cubed, x to the 4th. Now the negative 2, that's the y, negative 2. So negative 2 to the 4th. Add these together. So we're going to go down here. I haven't changed the formula. I'm just doing it more systematically because I'm looking at the combinatoric part first, then looking at the x part, then the y part. Same formula still. This way it's just a little easier to organize your thoughts. So let me first figure out these 4 chooses. I'll do the same thing as I did last time. 1, 4, 6, 4, 1. Now let's look at the negative 2. Negative 2 to the 4th is just regular 16. Negative 2 to the 3rd is negative 8, actually. So be careful here. Negative 2 squared is just regular 4. Negative 2 to the 1st is just regular negative 2. Negative 2 to the 0, anything to the 0 is 1. Let's get rid of all these 1s because they are no use to us. X to the 0, that's also 1. Let's get rid of that. Okay, now we can evaluate. I'm going to start out. I always like to write the biggest coefficient, biggest power first. X to the 4th. This one is minus 8x cubed. This one is plus 24x squared. This one is minus 32x. This one is plus 16. And that's the answer. Okay, any questions here? Any questions? If none, I'll go on. Let's skip this one. This one is a little more advanced, but you'll have plenty of practice in the homework. I'm going to move on to long division. Remember when you did long division back in 5th grade, right? Okay, 216 divided by 6. How did we do these long division problems? Well, you look at the first term. How many 6's can go into 2? We can't put any 6's into 2. Okay, let's look at 21 then. How many 6's go into 21? Aha, 3. So we put the 3 here. Now we do 6 times 3, 18, and we subtract 3. Move the next term down, 36. We repeat. How many 6's go into 3? We can't put any 6's into 3. Let's add the 6 in the help. How many 6's go into 36? 6. We multiply 6 into 6. We get 36, and we subtract 0. 36 with no remainder. Same exact thing with polynomials here. Same exact logic. So let's divide these two polynomials. So the first step when you're doing polynomials is just write it normally. You got x minus 3 on the outside, and the bigger polynomial normally in the inside. Okay. But the thing is, we have to write out every single term. Okay. We got to write out the x to the first term and every term. So if you see here, this polynomial doesn't have an x to the first term. So we have to add that in. We have to add 0x to the first. That's just what we do to make sure we don't get confused here. So it's 4. So I haven't really changed anything. I added 0x to the first because there is no x to the first. But I need that thing in there so our numbers are aligned. Remember when you did long division like this? Your numbers had to be aligned, right? If I did 18 and I put the 18 here, that wouldn't work. That would be a disaster, right? So this is just to help us align our values here by adding the 0x to the first two. Okay. We do the same exact thing. How many x's? So actually here, we're going to look at the first term of each polynomial now. Only the first term. When we did long division, we look at the whole number. Like if I did 36 times something like that, I would have to look at the whole number. But here, I'm only looking at the first term of each polynomial. So how many x's can fit into x to the third? How many x's? That's basically asking x times what can get me to x to the third? X squared, right? That gets me to x to the third. So x squared is up here. Now I multiply these just like I did in long division, but now I multiply the whole thing. So now if I multiply, I got x cubed minus 3x squared. Okay. And now I'm going to put that down here and subtract it. X cubed minus 3x squared. That numbers came from multiplying these. And as always, we'll subtract these. We'll subtract. Make sure you put the parentheses around. So negative 2x squared minus negative 3x squared. That gives us positive x squared. X cubed minus x cubed, that's 0. Move the rest of the terms down. We repeat. We do it again. How many x's can fit into x squared? X's can fit into x squared, right? If I have x times k equals x squared, x goes into there. So x is the next term. And we multiply x times x minus 3. That gets us x squared minus 3x. This is where it was important that we add 0x1 here, so our terms are aligned. Okay, we subtract as always. 0 minus negative 3, that's positive 3x. This turns into 0. Okay, free up a little room here. We do it again. How many x's can fit into 3x minus 4? How many x's can fit into 3x? I'm looking at the first terms here. So 3 x's can fit into 3x. So now we multiply again. 3 times x minus 3 is 3x minus 9. 5, 0. How many x's can fit into 5? We can't actually. So that's the remainder. 5 is our remainder here. Okay? So the quotient is x squared plus x plus 3. Our remainder is positive 5. Okay, so that's our answer. That's basically our answer. X squared plus x plus 3, remainder 5. Okay. So to find the precise value of what this division gives, I don't want to have this remainder in here. I want to add it in there. Remember when we had like, let's say we have 87 divided by 7. We can do all our stuff. 7 goes in 8 one time. Remainder 3, right? If the remainder is 3, the actual value of 87 divided by 7 is 12 plus 3 over 7. Right? We take the remainder, we divide it by the original, like the divisor, and that gives us our precise answer. Right? So we're going to do the same thing here. We're going to take 5 and we're going to divide it by the original divisor and add that to our quotient. This is the actual precise value of what this division gives. Okay, I have that remainder. I can leave the remainder out. Then it would just be the quotient plus the remainder with a remainder, right? But to find the actual value of this, just as I did here, we would have to add in the remainder divided by the divisor to get the precise value of the answer. Any questions for long division? If not, let's go to a sample problem here. So another sample. This one's a little more complicated, but it's basically the same idea. Remember, you add in, if there's no, here there's no x squared term, so you're gonna have to add a 0x squared in there. Here, there's actually no x squared term, you're gonna have to add 0x squared. That's 0x. So you're gonna have to rewrite these first, and then you can do the division. Okay, and it's the same idea. So I'm gonna really quick skip that, get to the problems. Let's do this long division here. Okay. The answer, once again, is going to be really complex, so you don't need to chat it to me. Let's take 5 minutes. All right, let's do this. So we need to first figure out if there's any missing terms that we need to fill in, right? First one, top one, the numerator, doesn't seem like it has missing terms, so we're all good. But you want to write them in descending order. For like the greatest power is first, second greatest is second. So make sure you write it that way. Divide this by 2x plus 3. Let's do the division. How many 2x's can fit into 2x to the third? X squared. But basically what doing here is 2x third over 2x. And that goes there, right? That's basically what we would do if we did regular division. So x squared goes up there, multiply these, and put it down below to subtract. So let's multiply them, 2x cubed plus 3x squared. And subtract these. 0 plus 4x squared. Move the next terms down. How many 2x's fit into 4x squared? That's basically asking, if we do this, what do we get? 2x. Now we multiply again, and we put it down below to be subtracted. So what we have is 4x squared plus 6x. We subtract that. 0 minus 4x is 9. How many 2x's can fit into negative 4x? That's basically what it's asking is, if we do this, what do we get? Negative 2. Now let's multiply. Put it down below to get subtracted. Minus 2x minus 6 minus 4x. Zero plus 15. We can't fit any more 2x's into 15, which means that's the remainder. You can write it as x squared plus 2x minus 2, remainder 15. Or you can add that remainder in by dividing it by the original quotient, original divisor. That's the actual answer. Okay, just like regular long division, it's just with polynomials, right? It looks a little complicated, but it's the idea is the same as regular long division. Let's just skip these problems real quick. We're going to work on something called synthetic division. Okay. Long division works for any polynomial. If you want to divide anything, it will always work. Synthetic, but it takes a long time, right? Long division is called long division because it does take a long time. So you got something called synthetic division, which allows us to divide things very quickly. But it only works if the divisor, which is the denominator, is an x to the power of 1 minus some kind of constant. Okay, it has to be a binomial, and it has to be the greatest power in there has to be x to the first. Okay, it cannot be x minus 3. Then we can't use synthetic division. It has an x to the first plus or minus some kind of constant. Okay, in this case, it was minus 3. Okay, so how to do synthetic division? It's very quick. So what we first do is we rewrite these equations always. And then we put in the coefficients here. We're going to write down the coefficients of the, what is that called? The dividend, the numerator. We're going to write down the coefficients. 1, negative 2, 0, negative 4. Write them from left to right in that order. Okay. Now what we do is we write a little box here. And we put this number here, 3. We put positive 3 here. Okay, remember that. So instead of putting negative 3, we're actually going to put positive 3. So it's going to be x, if we have like x minus a as our divisor, we put a in the little box. This is because if x minus a is like, I think this comes from like if x minus a is 0, then x equals a. That turns into a positive. So basically what we're doing is we're taking this number here. So if it was x plus 3, we would put -3 into this little box here. Okay. Now, what do? We're going to draw a line like this. The rule here, so we're going to start with 1. The rule here is going to take this number, we're going to add it down, subtract it, multiply it diagonally. So let me show you how that means here. We're going to take 1 and we're going to add it downwards. We're going to add 1 to the number below it. There's no number below it. We'll just pretend that's 0 right there. Okay? So if we add it down, we get 1. 1 plus 0 is 1. Now we multiply it diagonally. What that means is we take 1 and we multiply it by 3. We put it up there. 1 times 3 is 3. Repeat. Add downwards. 1. Multiply diagonally. Multiply by the 3 again. 3. Add downwards. 3. Multiply by the 3 again. 9 goes there. Add downwards. 5. Okay, so now we got these numbers here. 1, 1, 3, 5. The 1, 1, 3, those are the coefficients of our quotient. And the 5 is the remainder. Okay. So if you think about it, what must be the greatest power of the quotient? X cubed divided by x cubed plus something else over x plus something else. It makes sense that the greatest coefficient of the answer is going to be some kind of x squared, right? So it's going to be 1x squared plus 1x plus 3. Remainder is 5. Take out the ones here. They don't make any, they don't contribute anything. Our quotient is x squared plus x plus 3. And our remainder is 5. And that was a lot quicker, a lot easier than long division. I hope you can all agree with that. Okay. So yeah, that's basically it. That's why it's called synthetic division. It's so easy. It's so straightforward and so quick. That's almost fake. Synthetic means fake. Okay, it's almost fake because it's so awesome. Okay, so that's how you do synthetic division. As a recap, you write down the coefficients of the divisor, the dividend. Write down the coefficients. You put in this a in a tiny little box up the top, and you add down, subtract diagonally, no, multiply diagonally, and you repeat that until you have all these numbers in the bottom. Those are the first 3 are your coefficients. Not the first 3 necessarily, but the last one is the remainder. The other ones are the coefficients for your quotient. Okay, let's do these 2 synthetic division problems. I'll give you until the end of class to do them. Maybe a little bit over time, just so you can get these done. But these should be a lot faster than long division. All right. The first step is we write out the coefficients of the dividend, which is the numerator. Make sure there's no numbers, no coefficients missing here. Seems like there's nothing missing. So 1, -4, 2, and 5. We put +2 in the little box here. Remember, add down, multiply diagonally. So we're going to add down, basically 0 there. So the first one we just add down, we just get 1. Multiply with 2, and we put it up there. Add down, -2. Multiply by 2 and put it up there, -4. Add down, -2. Multiply by 2 and put it up there, -4. Add down. Now we're done. The last one is the remainder. So r equals 1. The other ones are the coefficients of our answer, which is x squared minus 2x minus 2. Okay. Next one is the same exact thing. If you can see here, there's something missing. There's no x term. Make sure we put that in there, because otherwise our synthetic division will mess up. We have a 0x in there. So if we write the coefficients of the dividend, we have 2, 4, 0, -5. I put a -3 here. Now I add down, multiply, add down, multiply, add down, multiply, add down. Last one's the remainder. So r equals -23. The rest of them are the coefficients of our answer. 2x. Voila. That's it. Okay. I want to look at something here. In this case, the coefficient on our x is not 1. It's not 1. But we can still use a synthetic division here. So what we need to do is actually factor out a 4. Factor out a 4. Because we put like that a value in the box there, right? The a value is not 3 because we got a 4 here. So what we have to do is we have to make an a value by factoring out that 4. And then we can use the synthetic division. So just remember that if we do the synthetic division here, there's an extra 1/4 factor. There's that extra 1/4 we have to multiply by our answer, and that would be it. So you do the same exact thing. It's a 3/4 would be in the box. 3 minus 2, 1 minus 10, etc. You do the same exact thing, and you get your answer. And remember to just divide by 4 in the end. Okay, so that's what you would do if the coefficient on the x was not 1. Most of the time, you're going to see the coefficient as 1. And then this is just to prepare you if you see that scenario. Yeah, that is it for today. Polynomials part 1, that's it. Next week, we'll be doing more advanced polynomials. You would see more like the Mathcounts competition. So I'll see you then.